Hi and welcome to the third class on number system. My name is Nishant and with me you have covered the last two classes where we started with classification of numbers. We went to rules of divisibility and then we looked at summation of natural numbers. That was the first class. In the second class we entirely focused on HCF and LCM. Also we looked at 3 LCM models and 2 HCF models. And now we are here in the third class where we are going to discuss all about factors. Okay, factors, earlier also I told you that factors or divisors are basically numbers that divide a given number completely. Okay, so one of the most important concepts of numbers, and numbers as a whole, I've told you multiple times, that gives you a lot of questions and definitely you get one or more questions from factors. So sit down, listen to me carefully, have pen and paper in hand, take notes, and after watching this, please do revisit, watch it multiple times so that you're absolutely clear with it, with each and every concept. Okay, so let's get moving. Now, when we talk of factors, basically first thing that we do is for any given number, we write it in this format. Okay, n is equal to a to the power p, b to the power q, c to the power r, and so on, where a, b, c are distinct prime factors. Very important, and this forms the core. And we are going to use this format for all our concepts. So let's just understand, for example, if you have 120 as a number. Okay, so 120 is 2, then you get 60, 2, you get 30, 2, you get 15, and then 3, and then 5, right? But this is not how you are going to write this. This is not how you are going to put the factors as. You are also not going to put it as this. Okay, all these are wrong because if you see, first they have to be distinct. Here you can see they are not distinct. These three of them are same. Second, they have to be prime. In the second case, they are distinct, but they are not prime. This is not prime. So how you are going to write it is 2 cube into 3 into 5. This is how you are going to factorize each and every number. It has to be distinct prime factors. You can put the powers, which is fine. Okay, but you can't have 2 into 2. If you have two 2's, you will mention 2 square. Okay, and 3 obviously means 3 to the power 1, 5 means 5 to the power 1. So if you compare with this format, a is equal to 3, a is equal to 2, b is equal to 3, c is equal to 5, p is equal to 3, p, q, r are the powers, q is equal to 1, and r is equal to 1. Okay. So always, each and every number will always be written in this kind of a format, which are distinct prime factors. Okay, so this forms the core. And with this, now we are going to look at 7 different types of problems that you can get with regard to factors. And we are going to discuss some formulas for doing each one of them. Okay. Normally you would have seen in my classes, I avoid giving you any formulas. I try to do with as little formulas as possible. Though here formulas would help because then they can significantly reduce your calculation time. So here we will rely on some formulas and it will be useful if you can remember them and apply them wherever required. Okay, so let's jump right in. So the first concept is this. Okay, so this is the first concept where we have to find the number of factors for any given number. Okay, this format, if you remember, this format on top remains the same. Okay, so when you write a number in this format, the number of factors is p plus 1, q plus 1, r plus 1, and so on. P, q, r, if you remember, are the powers. So going back to the number that we had taken, 120, I hope you remember the factors of 120. It was 2 cube into 3 into 5, right? These were the factors. So here we have, I told you, p is equal to 3, q is equal to 1, and r is equal to 1. This answer, if you see, has nothing to do with ABC. It only needs p, q, r. So my factors are going to be 3 plus 1, p plus 1, q plus 1, and r plus 1. So it is 4 into 2 into 2, which means 16. They are going to be 16 factors. Okay, let's also look at what are these 16 factors. I'll just list them down for you. So we'll have 1, 2, 3, 4, 5, 6. So everything up to here. Then 7 won't be there, 8 will be there, 9 won't be there, 10 will be there. Okay. Then you will have 12 will be there, 15 will be there, 20 will be there, 24 will be there, 30 will be there, 40 will be there, 60 will be there, and 120 will be there. So these are the 16 factors. Okay, if you count, you will see that you will get 16 factors, and these are the 16 factors. Okay, now please note, number of factors includes 1 and the number itself. So these 16 factors includes 1. As you can see, it also includes 120. So in case a question says that 1 and the number has to be excluded, then your answer will be this formula, -2. Okay, if only 1 has to be excluded, -1. If only the number has to be excluded, -1. If both of them have to be excluded, then -2. So your answer can be 16, 15 or 14 depending on what the question has been asked. Okay, then third very important point, number of factors is always even except in case of a perfect square. How many factors did we get here? 16, right? Now if you see, understand the concept here, your number of factors is p plus 1, q plus 1, r plus 1 and so on. Okay, if even one of them is even, your product will become even. Okay, let's assume that all of them are odd, 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 even. Your product will become even. And when p plus 1 is even, that means p is odd, right? P is odd. Q plus 1 is odd, that means q is even. And r plus 1 is odd, that means r is even. Okay, so you can see this is the case. Now what happens in the case when, now if you want a total number of factors to be odd, if you remember in the very first class we had discussed that you get an odd product only when all the numbers are odd. So p plus 1 has to be odd, q plus 1 has to be odd, r plus 1 has to be odd. Then only the number of factors will be odd. Okay, now if p plus 1 is odd, that means p is even. Q plus 1 is odd, that means q is even. R plus 1 is odd, that means r is even. So p is even, q is even, r is even, all the powers are even. That means the number is a perfect square. So that's where this comes from. Only in case of a perfect square, the total number of factors will be odd. Okay, let's take an example. Let's say I have a number 144. Okay, now 144 is 2 into 72, you get 2, 36, you get 2, 18, you get 2, 9, then you get 3, you get 3. So this will be written as 2 to the power 4 into 3 square. This is a perfect square. 144 is a perfect square because all the powers are even. Now, total number of factors for 144 will be 4 plus 1 into 2 plus 1. You can see the powers were even, so both the numbers will become odd. So you'll get 5 into 3, which is equal to 15. So you'll get 15 factors here. Okay, so the only case when you'll get odd number of factors is when the number is a perfect square. Otherwise, you'll get even number of factors always. Okay. Now, what are these factors? Let's also list down these factors and you will see a unique case here. For 144, if I look at the factors, I have 1, I have 2, I have 3, I have 4, I don't have 5, but I have 6, I have 8 also, I have 9 also, I don't have 10, I don't have 11, but I have 12. Okay, then how much do I have? 12, then you will have 13, no, 14, no, 15, no, you'll have 16. Okay, then you will have, will you have 18 also? 9 into 2, yes, 18. Then we'll have 24. Then you'll have 36. Then you'll have 48. Then you'll have 72. And then you'll have 144. Okay, so if you see now, total number of factors are 15, where 12 comes only once. Okay, 12 obviously will be counted only once. So these are, in fact, if you notice one thing, for when we did for 120 also, I wrote the factors like this. Okay, because actually if you see when 120 had 16 factors, when you reach midpoint, that is 8, then the factors start getting multiplied to give you the number. So when I wrote till 10, I had reached 8 factors. So then I started reversing, because 10 into 12 is 120, 8 into 15 is 120, 6 into 20 is 120, 5 into 24, 4 into 30, 3 into 40, 2 into 60, and 1 into 20. All these will give you 120. Okay, so if you reach midpoint, then it is very easy to find out the remaining factors. Same thing here also. If you see 1 into 44, 2 into 72, 3 into 48, 4 into 36, 6 into 24, 8 into 18, 9 into 16, all these are 144. 12 comes only once, because 12 into 12 is also 144. Okay, so 12 into 12 is also 144, but obviously 12 can be counted only once, hence the total number of factors are 15. Okay, sometimes question might say that the factors have to be distinct, the factors have to be same and all that. That will come in the next part, but I hope we are clear till here. Okay, let's do some questions to understand this better. Okay, so we have one question where actually 10 questions in one. Okay, but useful, because this will clear all your concepts regarding number of factors. So the number that we have taken is 2160, and in fact 2160 will take in a lot of questions, because we don't want you to spend unnecessary time in factorizing every number. So we'll take 2-3 numbers so that we can use the same factors again and again. So 2160 is equal to 2 into 1080. So 2 into 540, 2 into 270, 2 into 135, 3 into 45, 3 into 15, 3 into 5. This is what I get. So I can write that 2160 is equal to 1, 2, 3, 4. 2 to the power 4 into 3 cube into 5. So 4, 3 and 5 to the power 1. So this is my factor of 2160. I hope we are clear till here. So 2 to the power 4 is 16, 16 into 5 is 80, 80 into 27. Okay, 80 into 27 is what gives you this number. Okay. Now let's look at the questions. Some of this we have done and some of these are new, but you will understand how to approach each question. So the first question is total number of factors. Total number of factors obviously will be 4 plus 1 into 3 plus 1 into 1 plus 1. Right? You know the formula. So it is 5 into 4 into 2, that is 40. They are going to be 40 factors. We'll not list down the factors. 40 is too much, too many factors. So we'll not list down, but it is 5 into 4 into 2, which is 40 factors. So total number of factors are going to be 40. Okay, this we know. Total number of odd factors. Now this we had not done earlier. How many odd factors does the number have? Now what do you do to find out odd factors? And next question is also asking you even factors. What do you do for that basically is, see, there's only one number that can make a factor even, which is number 2, right? Because we are talking of prime distinct factor. 2 is the only prime distinct factor which will make a factor is even. So what we do when the question is about odd factor, you ignore 2. You ignore 2. Okay. So if I ignore 2, then my factors are 3 cube into 5 to the power 1. So whatever factors they make is going to be odd. And the moment you attach 2 to it, it will become even. So just focus on 3 to the power 5, 3 to the power 3 into 5 to the power 1 and apply your rule of factors. So then your factors are going to be 3 plus 1 into 1 plus 1, which is going to be 4 into 2, 8. So they are going to be 8 odd factors. The 8 factors which are odd. Total factors are 40. So obviously even factors are going to be 40 minus 8, which is 32. This is one method of solving. There is one more method of solving which I'll tell you. For the total number of factors, for the factor to be even, it has to be multiplied by a 2, right? So from this, take 1 2 out, which we will put in every factor. So basically I'll write this number as 2 into, if you take 1 2 out, it will be 2 cube into 3 cube into 5 to the power 1. Okay, so 1 2 I have taken out. Whatever factors we'll get from here, we will multiply it by 2. So obviously it will become even. So it has to be even because this 2 is definitely there. So we will find factors only for what is inside the bracket. Okay, so that will give me 3 plus 1 into 3 plus 1 into 1 plus 1. Okay, which is 4 into 4 into 2. So 4 into 4 is 16, 16 into 2 is 32. So you can use this method also. Okay, so this method also will give you the total number of factors which are even. We already have total number of factors which are odd. Okay, remember these because these are standard questions that can be asked. Okay, then total number of composite factors. This again is important, but very simple. All the factors are composite factors except these numbers themselves. Okay, 2 is a prime number, 3 is a prime number, 5 is a prime number. There is no other prime number because all the prime numbers are already listed here. There is one more number which is 1. 1 is neither prime nor composite. It is unique. Okay, but since the question is asking you for composite, we cannot count 1 also. So basically you will have to remove 1, you will have to remove 2, you will have to remove 3, and you will have to remove 5. Okay, so 1 is obviously there, 2, 3, 5 you can see here. So 1, 2, 3, 5 I have to remove. That means 4 factors you have to remove. So 40 minus 4, answer is 36. There are 36 composite factors and 4 factors non-composite, 3 of which are prime and 2, 3, 5, and 1 of them is neither prime nor composite. Okay, good so far? Fine. Let's move to the next one. Total number of factors that are multiple of 3. I hope you have got the approach for this. Okay, same that we did for even factors. When you want factors to be a multiple of 3, take 1 3 out. So if I take 1 3 out, what am I left with? 2 to the power 4 into 3 square into 5 to the power 1. So we'll find the factors inside and each factor will get multiplied by 3. So it has to be multiple of 3. Okay, so this will be 4 plus 1 into 2 plus 1 into 1 plus 1. Okay, so it is 5 into 3 into 2. Okay, 5 into 3 into 2, that is 30. So there are total of 30 factors out of 40 which are multiple of 3. Okay, total number of factors that are multiple of 12. Logic is exactly same. The only difference is 12 is a composite number, 3 was a prime number, but that makes no difference. 12 is equal to how much? 12 is equal to 2 square into 3, right? 4 into 3. So you will take 2 square into 3 out. So what am I left inside? 2 square you have taken out of 2 to the power 4. So 2 square is left. 3 had 3 to the power 3. 1 3 you have taken out. So you are left with 3 square and you are left with 5. So this is what we are left with and this is what we will factorize. So the answer will be 2 plus 1 into 2 plus 1 into 1 plus 1. So it is 3 into 3 into 2. So 3 into 3, 9, 9 into 2, 18. The 18 factors which are going to be multiple of 12. Fine. Okay. Okay, so in the next one, we want total number of factors that are perfect squares. Now this is interesting. For perfect square, each factor has to be an even power. So what we will do here is, we will only take, so 2 if we take, if 2 is there, it has to be in the form of 2 square, right? We have 2 to the power 4, which means 2 square to the power 2. Similarly, I will take 3 square. Now 3 square is to the power 3 is to the power 3. Power 3 is of no use to me. I will only take power 1. Okay, 1 3 is extra, but that third 3 will not make it a perfect square. And 5 is only to the power 1, so 5 I cannot take because minimum I need is 5 square. Okay, I hope you have understood this part. See, to be a perfect square, any factor should not be there, which is fine. 5 I can ignore completely. If it is there, it should be an even power. So here from 2 to the power 4, if I take 2 square, I can take to the power 2, which means 2 to the power 4, which is same thing. 3 is cube. 3 cube is there. If I take 3 square, I can take only power 1. One more 3 remains, but that I'll have to leave because that is of no use to me. Okay, so you'll only have to take multiples of 2. Okay, 4 is a multiple of 2. 3 is not a multiple of 2, so I'm only taking 2. 1, 3 I'm leaving. Okay, so this is how your number will become, and 5 I cannot take at all. So this is what you get. And now, so this basically is of the form a square into b to the power 1. This 2 square is a and 3 square is b. So this is, so your number of factors are going to be 2 plus 1 into 1 plus 1, which is 3 into 2, which is 6. They are going to be 6 numbers which are perfect squares. 2 plus 1 into 1 plus 1, which is 6. Which are these 6 numbers? In case you want to check, we can check from here. First case obviously will be ignore everything, so you get 1. 1 is a perfect square. Then second is 2 square, which is 4. Third is 3 square, which is 9. Fourth is you take 2 square, 4 into 3 square, or before that, I can take 2 square ka whole square, which is 16. Okay. Then I take 2 square, 4 into 3 square, which is 36. And then I take 16 into 9, which is 144. So these are the 6 factors you will get which are perfect squares. Okay. Fine. Then total number of factors that are perfect cube. Logic is very similar. Here we had taken second power. Now you'll have to take third power. So 2 to the power 4 into 3 cube into 5 to the power 1. You will take 2 cube. So power can only be 1. You have 2 to the power 4, but you will take only 2 to the power 3. Similarly 3 to the power 3. This I'll take whole of it. 5 I cannot take because that is giving me only 1 power. So it is basically 1, 1. So A is 2 cube, B is 3 cube. Your answer will be 1 plus 1 into 1 plus 1, which is 2 into 2, which is 4. So your answer is 1 plus 1 into 1 plus 1, that is equal to 4. So there are 4 of them which are perfect cube. Again, which 4? Again, not very difficult. From here you can figure that out. First is 1, second is 2 cube, which is 8, third is 3 cube, which is 27, and fourth is 2 cube into 3 cube, which is 8 into 27. 8 into 27 is how much? 216. Okay, so these are my 4 cubes. Okay, so these are my 4 answers. Fine. Okay, the next one, total number of factors that have units digit as 0. Okay, so now to get the units digit as 0, what do you need? Remember that unit digit 0, that means basically the number is getting multiplied by 10. And 10 is not a composite number. 10 basically is 2 into 5. So any number that has 2 and 5 in the factor will definitely end with a 0, right? So we will do the same thing that we had done here. You will take 2 and 5 out, 1, 2 and 1, 5 out, and look at the remaining. So then I'll get 2 cube into 3 cube into 5, but 5 I have already taken out, right? So you have this. So here it will be 3 plus 1 into 3 plus 1, which is 4 into 4, it is 16. So there are going to be 16 factors which will have 0 in the end. Okay, last question. Total number of factors that have last 2 digits as 0. Now last 2 digits as 0 means that the number ends with 100, and you can only end with 100 if you have 5 square into 2 square. Okay, Now you can see that the number itself does not have 5 square. It has only a single 5. So you can't get 5 square. It is just not possible. So in fact, this will be 0. There will be no factor that will end with 2 zeros in the end. Okay. So through this, we have done all different types of questions on factors. We have done even factor, odd factor, multiple of 3, multiple of 12, perfect square, perfect cube, 0, double 0, everything. Okay. So I hope we are absolutely clear here. Fine. Let us then move to the next concept. We'll do one more question on this. A number has 72 factors. What can be the maximum and minimum number of prime factors of this number? Okay. 72 is equal to what? First, let's factorize 72 itself. So 72 is equal to 2 into 36. So again 2 into 18. So again 2 into 9 into 3 into 3. Okay. Now if you remember factors, how do you get your factors? Your number of factors is equal to, if you remember the formula, p plus 1 into q plus 1 into r plus 1 and so on. And these are the number of factors. So if you look at this, then that tells you that p plus 1 is equal to 2, q plus 1 is equal to 2, r plus 1 is equal to 2. Then you have s plus 1 and you also have t plus 1. Okay, s plus 1 is equal to 3. So this is this, this is this, this is this, this is this, and this is this. That means the number is of the type a to the power. Now p plus 1 is equal to 2. That means p is equal to 1. So a to the power 1, b to the power 1, c to the power 1, d to the power 2, because s plus 1 is equal to 3. So that means s is equal to 2, and e to the power 2. Okay. So this is one possible format. So maximum number of prime factors can be 5. A, B, C, D, E. You can see maximum it can have 5 factors. Okay. This is maximum. But then you can also say that 72 can also be written as, now there are various combinations. I can write this into 2 into 3 into 3 into 4. This is also possible. Then the number becomes a to the power 1, b to the power 2, c to the power 2, d to the power 3. So it has 4 factors. 4 is also possible. Also I can write 72 as 4, 3 into 4 into 6. Then the number is of the type a square, b cube, and c to the power 5. Now it has 3 factors. Also 72 can be written as, you can see there's so many combinations, right? 8 into 9. So then the number is a to the power 7 into b to the power 8. It has 2 factors. And lastly, 72 can also be written as just 72, which means my number is a to the power 71. So the number of factors can vary from 1 to 5. In between, don't bother. Maximum can be 5, where you have broken down the total number of factors into as many prime factors as possible, not distinct, but as many prime as possible. So maximum prime factors would be 5 and minimum prime factor will be 1. Okay, so the question is, what can be the maximum and minimum number of prime factors of this number? Answer would be none of these, because the correct answer is 5 and 1. Right? Maximum number of prime factors is 5, minimum number of prime factors is 1. Okay, great. Let's do one more. A perfect square number n has 9 factors below its square root. Okay, this again is an interesting question, and if you remember, we had written the factors just a while back. Let me take you there. Here, for a perfect square, we had written the factors like this, right? So if you remember here, 144 was a perfect square, okay, which was 12 square. So till its square root is obviously 12. Below its square root, you had 1, 2, 3, 4, 5, 6, 7 factors. So above the square root also you'll have 7 factors, and one factor will be the square root itself. Okay, so if you see the formula, if you know that below the square root there are 7 factors, then total factors are going to be 7 into 2 plus 1. So this one is the square root itself. Okay, so 1 more than the double. Okay, using the same logic here, the perfect square n has 9 factors below its square root. So 9 are below, 9 will be above the square root, and 1 will be the square root itself because the number is a perfect square. So total number of factors are going to be 19. That's the first thing. 9 below the square root, 9 above the square root, and 1 is the square root. Okay, or what we saw just now, 9 into 2 plus 1. You'll have 19 factors. Now 19 itself is a prime number, right? So if a number has 19 factors, you can't break down 19 into multiples. So obviously that means that the number is of the type a to the power 18. Only that is possible because 19 is a prime number. You can't break it down into factors. So the number has to be of the type a to the power 18. Okay. So now we want to know the factors for n to the power 5. So if this number is raised to the power 5, then it will become a to the power 18 to the power 5, which will become a to the power 90. So for a to the power 90, the total number of factors are going to be 90 plus 1, which is 91. Using your formula, factors is a plus 1, b plus 1, you only have a. So 90 plus 1, total number of factors are going to be 91. Hence, 91 is the answer for this question. Okay, so you get a lot of questions like this, a lot of questions which are not direct application, but some thinking, some logic also has to be applied. But if you're clear with the core concept, you'll be able to do all these questions very, very easily, and very interesting questions are formed. So we are touching upon only some of them, but please practice as many questions, as many different varieties as possible for this, because this is a very important concept and so many questions are formed on this. Okay, now let's go back to the second formula or the second question, where we find out number of ways to express a number as a product of two factors. As a product of two factors, and this also partially we had done in the previous question. I'll just take you back there. This, if you remember, why did I write it like this? Because you can see that they become product of two factors become equal to the number. Okay, and you can see that when the number had 16 factors, you could make 8 pairs. Okay, so the answer for this is very simple. It is half of what we found in the previous case. Half of total number of factors. Okay, p plus 1, q plus 1, r plus 1 is nothing but total number of factors. So it is half of total number of factors. But remember, this is when the number is not a perfect square. N is not a perfect square. If n is a perfect square, your total number of factors, if you remember, will be an odd number. For example, when we took n is equal to 144, you got 15 factors, right? So 15 by 2 will be wrong. 15 by 2 will get 7.5, which is not fair. So when the number is a perfect square, we do a plus minus 1. Okay. When do we do plus 1? When do we do minus 1? We do a plus 1 when both the factors can be same, if that is allowed. So for 144, one pair will be 12 into 12. If this is allowed, then you do 15 plus 1, 16 by 2. You will see there are 8 pairs. Which are those 8 pairs? Again, if you remember here, we had these 7 pairs already there. 1, 2, 3, 4, 5, 6, 7. 8th pair will be 12 into 12. This also can be counted as a pair. So you'll get 8 pairs. But in case the question says that the pairs have to be distinct, both the factors should be different, then you will do 15 minus 1, which is 14. 14 by 2, you will get 7 pairs. 12 into 12 will not be counted. So as simple as that. Okay, so let's apply this on a couple of questions. Okay, so let us look at this question, a very interesting question. For the number 3600, so 3600 is a perfect square. Let's first factorize it. So n is equal to 3600, you know, is 60 square. 60 is basically 2, then you have 30, then 2, then you have 15, then 3, then 5. So 3600 is square of this. Okay, so 3600 is 2 to the power 4 into 3 square into 5 square. Okay, given that this is the number, let's look at the first question. In how many ways can the number be written as a product of two numbers? This doesn't say that the two numbers should be same or different, so we'll assume that same is also allowed. That's the default assumption. So your answer is going to be half of 4 plus 1, 2 plus 1 into 2 plus 1 plus 1. Okay, so it is 5 into 3 into 3 plus 1. 5 into 3 is 15, 15 into 3 is 45, 45 plus 1 is 46, half of 46 is 23. So they are going to be 23 pairs of factors. Okay, as we discuss in the concepts. Second is product of two different factors. Exactly same answer, the only thing is here in 23, one of the factors will be 60 into 60, which is a square root into square root. Okay, in the second one that is not allowed. So you'll basically, instead of plus 1, you'll do minus 1. So it will be 45 minus 1, 44, half of 44, your answer will be 22. Okay, all same except this, 60 into 60 will not be counted. Okay, then we have three slightly different questions. In how many ways can the number be written as a product of two odd numbers? Now if you see product of two odd numbers, that means basically odd into odd should give you 3600, which is even, hence it is not possible. So two odds can never give you 3600, so obviously answer for this is 0. Okay, so this you need not solve. So in fact your 3600 can be odd into even into odd, or even into even. These are the possibilities. Odd into odd is not a possibility. And the next two questions are saying exactly that. In how many ways can the number be written as product of two even numbers? Now product of two even numbers, let's see here. Now that means basically 3600 should be written as 2a into 2b, right? That means 2 square will by default be there and you have to factorize a into b. So if you take 2 square out, then you are left with 2 square into 3 square into 5 square. Right? That is what we'll get. So factorizing this, you know, half of 2 plus 1, 2 plus 1, 2 plus 1, plus 1, because again it doesn't say that they have to be distinct. So basically 3 into 3 into 3 plus 1, half. So you will get 27 plus 1, 28 by 2, you will get 14. So there are 14 factors, 14 pair of factors where both of them are even. Okay. Then the last question is, in how many ways can it be written as a product of two numbers such that one is odd, one is even? Now one is I can solve this. Second is you already have the answer. If you see total number of factors are 23. Okay. So this is 23. Out of which odd into odd obviously is 0. Even into even we found it to be 14. So 1 even, 1 odd, or 1 odd, 1 even obviously has to be 23 minus 14. This should be equal to 9. Okay, so I can say the answer is 9 without even solving because I have solved the remaining cases. But if you want to solve this, one factor should be even. That means the whole power of 2 should go with one factor. Right? So now my number 3600 will be written as 2 to the power 4 A into B. I should not leave any power of 2 with B. Then B becomes odd. Okay. So if I take 2 to the power 4 out, what am I left with? 3 square into 5 square. Okay. So factorizing this, you will get 2 plus 1 into 2 plus 1, which is equal to 9 factors. So you will get 9 factors here. Okay. You may ask a question here, why are we not doing half of it? Okay, we are not doing half of it because basically you take odd into even, you also take even into odd. You take both combinations. So 1/2 will go here, 1/2 will go here. Total all this together, you will get 9 such combinations. Okay, so there are 9 combinations where one of them is going to be odd, one of them is going to be even. Okay, so 9, 0, 14, total of 23. Okay, so I hope we have understood this.